Example 7 wants us to find the domain of the composite function. So let's start out by finding f(g) of x. So start with f of x is x squared minus 9. Take out the x, I'm going to put in g. So that leaves me with f of g of x equals parentheses squared minus 9 because I took out x. In the place of x, I'm going to put the square root of 9 minus x squared. So square root of 9 minus x squared goes there. Now we're going to simplify. Squaring and square root undoes each other, so it gives me 9 minus x squared minus 9. 9 and negative 9 cancel. For f g of x equals negative x squared. Now at first we think the domain is going to be all real numbers because there's nothing that x can't be there. But we have to go into f and g first. So for f, being x squared minus 9, the domain is all real numbers. But for g of x, I have to set 9 minus x squared greater than or equal to 0. And that gives me negative x squared greater than or equal to negative 9. X is less than or equal to 9, x squared that is. And when I square root both sides, that gives me x is less than or equal to 3. But the negative portion flips the square root sign for greater than or equal to negative 3, and therefore it looks like this. Negative 3 to 3. If I put both domains on a number line, f of x on top, it goes forever in all directions. For the domain of g, it only goes from negative 3 to 3. And so I take the composition of the function, meaning what do they both have in common? And they both have in common negative 3 to 3. So my domain for f of g of x is negative 3 to 3.